In today's lecture, we will be discussing about more about the main principles of the microservices. Let me open the notepad here. So in today's lecture, let me write what we are gonna discuss. Some of the main principles of the microservices, and one of those is design for failure. So what does it mean is like failure may happen as your service are waiting for some of the database connections, and a database is full. We can say some hard disk is full. Some services are maybe out of memory, or they can be an issue for a CPU running 100%. So we can say failure may happen as your service may be waiting for database connections, and database is full, some hard disk is full, some we can say services are out of memory. I'm taking this as just as an example, or we can say CPU is running 100%. So these are the problems that may occur, and we must design our services in such a way that it must be designed for failure, like it must be designed such that these problems needs to be solved. For that, first we must use circuit breaker. Let me tell you what the circuit breaker are. It is just we can take the real life example, as there is a switch and we are there is a bulb that is connected to that switch through a wire. Once we switch on, the bulb will blow. Once we switch off, the bulb will not blow. But if we break the wire that connects that switch to that bulb, in that case we are breaking that wire. It will not provide the connection with the switch and the bulb. Now similar case is happen in the technical world as well. In our Spring Boot application, there is a library called resilience 4G. So this is a library, and this needs to be import into your project, and we can add some of the annotations to use that. And this is how we can use the circuit breaker. And apart from that, we have timeout handling problem. I'll show you how all these same library will be used for this purpose as well. I'll show you how it will work. Let me take an example. Let me open this whiteboard. I'll show you how it works. Let's here we have a service one, and here we have another service. Let me write over here. This is our service one, and this is our service two. Once we are sending some data from service 1 to service 2, we expect the response from service 2 to 1. But there is once in first attempt, we see we are not getting any response back. In second attempt as well, no results. In third attempt as well, no results. Like we are not getting any response. So after that, what we'll do, we will like again we are trying to ask for some of the data and we are not getting the response. Now what we will do, we will break this connection. This is what the circuit breaker is. This is how we will be working with the circuit breaker, or we can say here we'll install a circuit breaker. What it will do is it will automatically return back. It will not reach from service 1 to service 2. Rather, from here itself, the, the data will come back with an error message that it is not working for now. And this only happens for some few time that we will fix. It is for some 10 seconds, 20 seconds, and after that, it will recheck that. If we are getting the response, that means the problem has solved now. Otherwise, again no result, again we put the circuit breaker. And so this is how, like, we are trying to reduce the rush over service 2 for the incoming data. So circuit breaker will itself manage it and will return with no response. It need not to move from service 1 to service 2 exactly, but in between it will return back. So this is how we can write over here as well for the circuit breaker. Let me write over here itself. After some attempts, if after some attempts of connections, you already realized that the destination service is not working. So you stop calling that service, rather directly assume failure and process it like a failure at your end. And it will be, or we can say, it will resume after some time, whatever we decide. So this is how circuit breaker work. So we will implement this circuit breaker and for some time and then it will check again, or we can say it will check again after this particular time. So this is how circuit breaker and timeout handling, we can say as well, this is how it all works. Now apart from that, the problem can be resolved using monitoring, we can say. Basically, there is health monitoring and the alerts will be there, and we may have some monitoring dashboards that will give us update on whatever, like how many requests are there. We get the data here. We get the data about how many requests are there, how much RAM is using, and all such information we can say. So it all needs to avoid the system clash. So what it is actually doing is it is monitoring the health of our system, like how CPU is running, how RAM is running, how memory is occupied. So in this way it is all monitoring the health basically. And most important thing is Spring Boot actuator is a default health monitoring software or system, we can say, that automatically monitor, and for that we need to add some dependencies into our project, and again using some annotations and all, we can use it. And apart from that, we have our fourth way of solving the problem is distributed login. What does it mean is basically, in Spring Boot 2.x, we have sloth library for this purpose, and for Spring Boot 3.x we have micrometer and brave library for this purpose. What does it mean is basically it will provide the logs, like it will provide trace ID and the scan ID basically. Like the trace ID is the ID that is same throughout the project. Let me write over here, which is same throughout the project, and the scan IDs which has each log has its own scan ID. So this is how it works. Let me show you with the diagram itself. Apart from this, we can have, like we have different services we can consider here. This is service 1, then we have service 2, then we have service 3, and each service has its own logs. We can say each service has its own logs here, and here we must represent it as log 1 here. Here we have log 2, and here we have log 3. Now if we talk about the trace ID here, trace ID, I'll take an example 1 to 3. It will be same for all of these, it will be same for all. And if we combine all these logs, if we combine all these logs here and here, we will get all logs in one, and we can term it as Here all logs, let me write over here, all logs in one as Kibana. Basically, let me tell you what it is. This is where all logs are being placed. We can take an example for ELK, which is Elastic Search Logstack and Kibana. So this is where the system can do combine all log from all places to the center system, which we call Kibana here. This is the central system where all the logs are being combined. So this is how we can do the distributed login. So this is the main principle, one of the main principle for the microservices that is designed for the failure. So considering all the failure attempts, as we have discussed, database is full, or HD is full, or the service is out of memory, CP is running 100%. So considering all these problems, we must already prepare our services to deal with these failure. So we must include circuit breakers, timeout handling, we must have some health monitoring system, and we must use distributed login. Apart from that, we have one more principle of microservices that we are going to discuss today itself. The second one that we are gonna discuss is decentralized data management. What it is basically, as we know, every microservice has its own database. Let me represent it with DB here. Basically, let me show you with an example itself. Here, let's we have different microservices here. This is one of the microservice. This is another one, and this is another one. So when all of them are being connected through single database, so this is what we call as, this is where all of these are connected here. So this is centralized arrangement, data management. And we do not want this. We want all the microservices. Let me write it over here and take another set of microservices here. So we want all of the microservices. Say here we have three different microservices. We want all of them has their own database that can be represented as, this is one database, this is the another one, and this is another one. So here in this case we have, this is microservice 1, this is microservice 2, this is microservice 3, and this is database 1, this is database 2, and this is database 3. So this is what we call as decentralized. This is nothing but decentralized data management. So this is what we are saying, that we must have decentralized data management. Like one service cannot go to the second services database. Or let me write over here. What does it mean? One microservice cannot go to the database of second microservice, and even back. Either give only, read only data directly. So basically, what the database is, let me write over here, which is the heart of the system. Like if it is crashed or if it is not working properly, then whole of the data will be vanished. Whenever basically database uses with permission uh, to basically we must have, we can have database that may be physical or logical. Physical, that we can take an example that we are using MySQL, that is the physical database. And considering all these that are working, a logical database that is manually present. And wherever our application run, basically wherever our application run, there are 5 different environments. One is local environment, second one is dev environment, third one is QA environment, fourth one is UAT environment, and the fifth one is production level environment. Now, what does all this mean? Local environment is basically project run in your local machine. When dev environment, basically when the project is running in AWS, it is development or developer will test over here. When the project is running in cloud, QA will test here, and here developer will test. UAT environment is user accepting testing, basically. Apart from that, the last one we have is the production environment, which is live for the customer. And for this production environment, they must, let me write, for the production environment, they must have backup. They basically do master slave, as let me show you here itself. Like here is one data system that we have. This is one, and similarly these are further connected with another database. Let me represent over here. So here we have another set of databases. This is one, this is second one, and this is third one. And let me enclose it here as this one. So this is what we call, this is the master set, and this is the slave one. Whenever whenever there is some issue with the master, then slave will work on it. like s- all the data will be saved in these databases as well as over here itself. Whenever, if this is the primary one, if primary goes wrong or down, then the secondary become primary. And this is how it works. They have slaves, and apart from that they must have disaster recovery setup. Like disaster happen, like we can say earthquake can come. In this way, we need to save the data at different countries. So this is AWS, how it work. Like it have multiple data centers in different regions, although virtual and behind the scene available, but it is in the physically in the world. Although we can visualize it virtually only, but physically it is present somewhere in the world itself. So for that purpose, we can say right over here, whenever primary setup, or we can say master, goes wrong or is down, then secondary, or we can say slave, becomes primary. This is how it works. So for this we have disaster recovery setup. As in AWS, we have multiple data setups to deal with such disasters. It is present in different regions, and although it seems virtual to us, but it is available physically somewhere in the world. This is how it works. Like if there is some disaster at one of the region, then we can work on the second region. This is how all the data can be saved, or we can protect the data from our database. And this is how it works. So these are the main two principles of microservices that we need to consider while working on microservices. The first one, as we have discussed, is for the design for failure, and the second one is decentralized data management. Like we are not managing the data at only single center point, but we are decentralized it. We have different database for the different services, and they are all present at different regions in the world. So it all represents it all happens just to, let me clear it out. This is the repeated one, yeah. So this is how we can protect our data. If sometimes there is a clash or there is some disaster happen. So avoiding such conditions, or to avoid such situations, we are having aws at the we are having multiple data setups to deal with such disasters, and it is present in different regions, so that if there is some disaster at one region, we can deal with another one. So this is what we discussed for today as two of the main principles of the microservices. We'll discuss more principles in our next video. Thank you. Thank you for watching. Thank you.